Okay, guys. Well, thank you for coming, guys. So, a few months back, or actually last year, I was at Devoxx Belgium, and there was this really cool keynote from Dodge Hudson. He was talking about the imposter syndrome of developers. And literally every time, I've been standing in front of a crowd a few times now, every time I feel again like, okay, I'm going to be talking to people who really know what they're doing. And so this is cool. I'm really thankful that you guys are here to talk together with me about Doomsday prepping Keycloak and how to survive the apocalypse with Keycloak. So to give you a short intro, I want to take you on a time travel a few years back, actually to the year 2020, when at least for me in my life, something happened for the first time. So this little bugger hit the world. It's called the coronavirus. You know, within weeks, it engulfed the whole world. And for the first time, I was facing some really existential thoughts. So I have two children, and I was like literally starting to think, okay, what happens if global supply chains collapse? What happens if I can't get water any longer? If it's getting hard to find food? Medicine and healthcare, a really important factor. I think we've seen so many news reports where people actually face situations where they couldn't find oxygen for their sick loved ones. And shelter. I mean, if global supply chains collapse, you know, we're facing really dangerous situations where even shelter might not be guaranteed any longer. So I was really, you know, getting these doomsday prepper thoughts in my head, which I've never faced before in my life. Eventually, what couldn't I get? At least in the Netherlands, it was toilet paper. You know, everything was available except toilet paper. So yeah, but that really got me thinking, and that's basically how we got to think about, okay, how are we going to doomsday prep our Keycloak instance? So I'm Maik. I'm a senior software craftsman in the Netherlands for a consulting company, and I'm a technical coach and speaker traveling throughout the countries of Europe and delivering my Keycloak knowledge to whomever will listen to me. So thank you for being here. So I would first like to get to know you guys by asking you can get out your phone, scan the QR code, and give me a brief insight how much experience I am facing here in the room, if you have worked with Keycloak or not. I will give you like about 30 seconds to complete this. So the one person answering this was me. Okay, nice. Okay. It's really good. So we're seeing some people who've worked on hobby projects, some people who are actually working on a daily basis with this. So I think that's a good ratio to continue with this talk. So let's talk about Doomsday prepping Keycloak. For those who do not know Keycloak, Keycloak is an open source project by Red Hat. It is basically an IDP provider that provides you with multiple protocols like OpenID Connect, SAML, and so on and so forth. It's a very extensible platform since it's open source, so it does not provide you only with functionality out of the box, but it also enables you to write your own extensions, to customize code. Basically anything you can imagine, you can insert into your own Keycloak implementation. Obviously, it provides you out of the box with integration with the most famous external IDP providers like Google, GitHub, Facebook, Apple, whatsoever. You know, those are standard building blocks in Keycloak. Internally, Keycloak comes with building blocks which are called a realm, which is the most basic building block, which is like a bounded context within Keycloak, meaning that one realm is like an isolated instance from another realm. One realm, unless you write custom code to do so, will never be able to cross boundaries to another realm. You have clients, you have roles, you have groups, users, and so much more you can work with. I see people nodding here, so This is a very basic representation of what Keycloak can do. You know, we see let's see if my nice pointer works here. We see a realm here that actually contains the clients, the users, authentication flows. You can have out-of-the-box browser authentication flows. It comes packaged with certain authentication flows, but obviously you can also build your own because every company has different requirements for authentication of their users. You can have roles and groups and, you know, special groupings of rules of composite rules that you need to place together. So there are a lot of things you can do, and mainly a lot of configurations that you can do with Keycloak. And somehow you need to be able to introduce these into Keycloak. So this is what we will be talking about today. So mainly these are some of the manners on how to configure Keycloak, which is the most basic one, the admin UI. So basically you log into Keycloak and then you click things together in the user interface. There's the admin CLI that Keycloak ships to you, meaning you can, you know, give credentials to a command line interface and then trigger some commands to configure your Keycloak instances. That's somewhat automated approach depending on how you do this. We will get to that in a minute. I've seen a lot of projects that use configuration via JSON files. Basically, you're reaching that by configuring your Keycloak instance via the UI and then exporting it to a JSON file, and you can introduce that to your version control. I've quite recently at the Keycloak Dev Day for the first time heard that, I mean, I've been working with Keycloak for quite some years, but I've seen various people there configuring Keycloak instances with Terraform. So I've personally never done that, but apparently that works. So I put it on the list just today. It was not part of the talk before. So my next question to you guys would be, how are you configuring Keycloak? And I will give you again a few seconds to complete that questionnaire. Good one. It's nice to have you in this talk. I hope you will be using my way in the future. Okay. Okay, so just to give you some insights, we're seeing roughly the same statistics as in Devoxx Belgium last year. So there was also roughly 50% using the admin UI. So I'm really glad that you're sitting here in this talk and I can teach you something new. For those who have never configured anything, we've seen those in the slide deck just now. I will briefly show you what it looks like to log into the admin UI. And bear with me because I need to coordinate my fingers with this now, with the view. So this is basically what the admin UI of Keycloak looks like, right? We are here, we have the realm selections. This is by default a realm that is, when you launch Keycloak, is there. It's the master realm. That's basically the admin realm that you should never expose to your users. So whatever you do, don't let users access your master realm. So we can create a realm here. We just do something really basic. So we call this Devoxx, our Devoxx realm. It's enabled, and we say create. Oh, and I'm locked. Okay, I'm locked out. Look back in. Yes, okay, I know this is not a secure password. Don't hack me, it's admin. Yes, okay. So we basically now we created the realm test. You know, we can have a look at the default clients that it comes with. We can create our Devoxx client. Oops, sorry. It's really hard from this keyboard to this one. Next. So we want just a standard authentication flow with a direct access grant, which is fine for now. We do not configure any redirect URLs or anything, and we click Save. So we've just created our first client in Keycloak, which is called Devoxx, which is enough for now for our demo purposes. I will walk you through the same scenario with different configuration possibilities right now. So let's go back to our slide deck, and I will change the view again just to make this a little bigger. Yes. Okay, so that was the admin UI. There are some pros to doing this. It's easily clicked together in a way, and you don't need a lot of teaching to enable people to do this. And then, well, anybody with credentials can basically do this as long as he has some basic knowledge of Keycloak. The downside of doing the admin UI, anyone with credentials can do it. So whoever obtains the admin credentials of your Keycloak instance can mess with your configurations, can insert stuff that should not be there, or actually mess up your configurations. Because, I mean, Keycloak is, in a way, if you go into more advanced use cases, a bit complex to put together. And we also get to the problem that release versioning is not possible. If you click something together in the admin UI, you basically need to go to a Confluence page or whatever and document very meticulously the steps that you have taken to reach such a configuration. So I was in a project where we actually did this. And, at some point we were facing this Doomsday prepping scenario where we said, okay, what happens if our database gets corrupted, or we're losing a database? Okay, you can do backups, but still you need to maybe a backup is like a day old or a week old, and some configurations changed, and then you want to be online as fast as possible again. So to reduce that delta, we really had to think about how are we going to do this. So that's basically the motivation behind it. There are other cons to doing this, which is the testability is really limited. I mean, you can have integration tests, you can have acceptance tests from your market or from your business. Does the login still work? Does it work as expected? Do you pass certain steps? But there's no automated approach to this if you use the admin UI. And obviously complex recovery scenarios, we've just covered that. There's the admin CLI. There's some automation going on because you can actually open a repository. You can write a bash script for configuring your Keycloak instance, and then just trigger that bash script. Sorry. By that we actually get version control, and you get like some sort of release versioning if you package your bash script into I don't know, just whatever, a jar or whatever, and then you trigger it, just as an example, right? Downside to this, the CLI code is hardly readable, especially if you tackle some more complex scenarios. If you don't have idempotent configuration and you need to check if the client is already existing and you want to add it to a particular realm, so you need to retrieve IDs, and doing all of that in bash script it's not pretty, let me tell you, because we've also done this, and we have had bash scripts that were like 1,500 lines or longer, and it's just, the person who wrote it can quite possibly find its way through it and, know where you need to be. But, I mean, we are developers, and we like to change assignments, and then after 2 years, the person who wrote it left, and then, he tried to onboard somebody in a way, and then things need to change, and it's very easy to mess up in the end. And what we've also experienced, the execution time of the admin CLI is really slow. Why? Because for each command that you're executing in the background, it spins up a JVM, executes it, then shuts it down. And for the next command as well. And it sums up. If you have like 1,500, 3,000, 5,000 configuration commands, you can do the math. It will take really long. We ended up at some stage, I think, with 45 minutes of deployment time, which is just unacceptable. JSON files. So version control is possible theoretically if JSON would always be ordered, but it's not. So you can have some configuration automation, but version control is literally a nightmare. JSONs are just by nature not sorted, so whenever, or let's imagine a developer has a different IDE setting. He doesn't use 2 spaces, but 4. And then we get a diff on a 50,000 lines long file that is just uncomparable to the human eye. We have ChatGPT now. It possibly might be able to change to tell you what the differences are, but it's just not manageable in big enterprise projects. The secret maintenance in JSON files is also really complex because, when you export the JSON from Keycloak, it will actually put the encrypted secret into the JSON file with the key that was at that time in your Keycloak instance. What happens if the key changes? Then suddenly Keycloak cannot decrypt the secrets any longer in your JSON file. So that is also something you need to take into consideration when using JSON files. Also, you're really dependent on logic from Keycloak. The export functionality might change in the future. First, the order is not guaranteed. We already established that. But they might export different fields in a client or in a user. They might change the user model. So it's not guaranteed that you always get the same output when exporting these configurations. Also, migration to newer versions complicates that because, as I said, the JSON might change. So, taking all that into consideration, and we don't know any better, and we happily put together our configuration using the admin UI or using JSON files or the CLI, what could possibly go wrong? Let me tell you, everything. So I'm really curious to hear, for those people who have worked with Keycloak in production environments or even in hobby projects, I don't know how advanced your setups are at home, what apocalyptic scenarios you faced as a developer when working with Keycloak on projects. I'll give you a bit more time, like a minute on this one, to write down some stuff. Good one. Never erase your production database. Okay. Wow. Okay, yeah, I'm seeing a lot of interesting stuff. Let me tell you, we have also faced some of these issues, and that's why we started thinking about Doomsday prepping. So let's continue. Pitfalls and other apocalypses that we have faced are actually configurations gone wrong, that we, in our ignorance, we thought that we would do the correct configuration, but it actually did not work. Deployments gone wrong. We used to be in, I'm trying to remember the name of the cloud, doesn't really matter. Anyways, the CI/CD pipeline took a really long time. And when we deployed our bash script, which was taking 45 minutes, it was just insane. And because our deployment pipeline timed out after 20 minutes. And then it was like, well, all the 20 minutes that we've just passed, they're literally gone to waste because, we had to trigger it again. So we had to figure out a way to circumvent this deployment pipeline timeout to actually be able to trigger our configuration. Demise of knowledge, I already tackled that. We just switch projects from time to time, and you need to maintain like a certain level of knowledge to be able to keep up with the configurations of your Keycloak instance. And then we said this, like, yeah, but we've only changed this one small thing, and now users cannot log in any longer, and the management is going like, what did you do? And users cannot log in any longer. Yeah, so it's really stressful times, and you somewhat want to prevent this from happening. Missing configurations, we had this Confluence page where we said, okay, you need to execute this and this and this step, and we're just humans, so if you do a deployment at 5 o'clock or 4 o'clock in the morning, people are tired and they tend to sometimes miss some steps maybe, and then they say, okay, we execute every step of the configuration, something was missed, and then it doesn't work as expected. And then these guys come, and they make your life a living hell. So we had issues, you know, where suddenly at 3 o'clock in the afternoon on a Saturday, we got like a call from the manager, said like, we have this huge peak in log messages. They're like 15, 20, 25,000 messages in 3 seconds, and somebody's trying to hack our Keycloak instance. And we were like, okay, but you know, right now there are no known security vulnerabilities for the version we are currently using. But no, but I don't care. You need to look into this. And then we were sitting there with 25,000 log messages, and how do you go through them and determine if they got somewhere? So this cost us eventually like a week of incident reporting and post-mortem analysis, which we also said in our Doomsday prep session, like, we do not want to do this any longer. This is a waste of our time. We'd rather be developing features. So how can we prevent this from happening? This is us being really desperate doing the analysis. So we asked ourselves the following questions in our Doomsday prep analysis. How do we reduce risk and enhance security of our Keycloak instance? How do we reduce recovery time when something happens without having to reconfigure everything, walking through Confluence pages or, you know, reinserting JSON files into the Keycloak instance? We wanted to like 100% automate the whole procedure. How to reduce stealth data during recovery? Basically meaning that, you know, if I have a really advanced cloud setup where I have automated backups, a really ideal setup, there will still be deltas in your backups, even if you do them every hour. If it happens on minute 59 before the backup is being triggered, you have a state delta of 59 minutes where you do not know what happened. You might, if you're a really big company, you might have, I don't know, 100 users that signed up and their accounts are literally gone because you had to, you know, play in a backup of your database. Also, how do we enhance maintainability so that just as in a Java project or any other project, I mean, we're mostly Java developers, I think, here because of Devoxx, but you know, how do we enhance maintainability and testability, that we can actually get version control on our configuration code? Our solution was the Keycloak Java Admin Client. It's also a client maintained by Keycloak, and it's basically enabling you to write your configuration in Java code, making it unit testable, making it integration testable, making it possible to have version control, and basically answering all of our requirements. The only thing we had to do is adding, in a very basic setup, these 3 dependencies to our POM.xml, and that enabled us to write code that looks somewhat like this, where we have a set of Keycloak configuration properties, which were like the server host, the admin user, a password, and the configuration realm, and that basically opened up a Keycloak client, which allowed us to call, you know, realms resources, clients resources, and so on and so forth, and execute operations on these. This setup basically led us to a situation where we have a module in our project where all the Keycloak code is contained. Some extensions in Keycloak need to be packaged into the Keycloak image. Think of, for example, protocol mappers, identity providers, custom authenticators that you add to authentication flows. All of these need to be made available to Keycloak in its image. And then we had a second module, the configuration code, which was a jar containing every single configuration of a client, of a realm, of a assignment of a protocol mapper to a client, client scopes, roles, whatever you can imagine, right? Everything contained in here and packaged into our custom Keycloak Docker image. You could even customize themes. There's a really nice library called Keycloakify. It's not that known yet. You can actually not use these really ugly free marker templates, I see nodding there, but you can actually write a React application that customizes the whole theming of your Keycloak instance. Any extra services you might want to add, or libraries, which is also really important. If you follow this sort of custom approach, you're actually in full control of the dependencies added to your Keycloak Docker image. So if you have really strong security requirements, for example, you can actually customize and exclude certain dependencies from your Docker image. So what did that give us? In general, we have configuration automation, we have version control, and actually enabling multiple teams to collaborate on the same Keycloak instance. Because it's just pull requests, the same version control we're using on any other code project that we are working on. We get the packaging and release versioning. We could actually package an artifact and pair a set of configurations with an image from Keycloak. For example, this configuration particularly works with Keycloak 21. And then I have another artifact where we packaged Keycloak 22 with a future set of configurations. So we always know which configuration belongs to which version of Keycloak. And there's no cons. We have more pros. You have code readability. We had this bash script, which was totally unreadable, but Java code is readable to us now. We're Java developers, so we can read the configuration that we are creating. We have testability. We can unit test our Java code. We can integration test, as I said. And we have almost no added complexity for bigger projects, because you can actually reuse certain parts of your code. You can write helper classes that help you create a realm, that help you create a client, that help you create whatever, and just reuse them and very well structure them to create the requirements of your project. So that basically led us to the next analysis step, where we said, okay, we in our project encounter two scenarios, and we split that up into static and dynamic. Let me first talk about static configuration. Static configuration basically means that in our setup, we end up with a set of configurations that is versioned, packaged in an artifact, and at the time of deployment, deployed to our environment, the configuration is being triggered, and that's it. Nobody will touch the configuration, until the next deployment. Basically making it static. And in our setup, we actually ended up with a stateless Keycloak, meaning that there's no dynamic configurations happening, and also there's no data introduced into Keycloak that introduces some sort of state. What that means, or what I'm referring to with this, is that we actually externalized everything from Keycloak that is not configuration. There were no users in Keycloak any longer because we implemented user storage providers. There were no credentials in Keycloak any longer, except for the confidential client credentials where you needed a client secret. But any passwords from users, we stored them externally from Keycloak, essentially rendering our Keycloak instance entirely stateless, except for its configuration. And that we could replay without a problem by just triggering the jar or another deployment without any problems. So let's play through this scenario. At some point in time, we deploy our Keycloak instance. Let's assume an empty database. We deploy our Keycloak instance, Keycloak starts up, it executes its Liquibase script, the basic thing, and you end up with an entirely empty Keycloak, as you would if you spin up the Docker image. And then our deployment pipeline, as whatever post-deployment hook whatsoever, triggers the execution of the jar, returning Keycloak to the state that we expect with all the sets of configurations that we have coded in our Java configuration. And then we happy go on about our work. And then Saturday, 3 p.m., the script kiddie that I was mentioning tries to hack our Keycloak instance and may or may not have gotten somewhere, you know. And our manager calls us and says like, well, I want to know what happened. And we say, well, sorry, but we don't care. The only thing what we are going to do is throw away the database, trigger deployment, trigger our configuration, and within 30 seconds, we are back to where we were. Because our Keycloak is stateless, and we can simply say we are redeploying. We might rotate secrets if we wanted to, you know. We don't care because if they have gotten somewhere, anything they might have changed or tampered with whatsoever will be gone in a second because we just wiped everything and redeployed it. And then we came to another scenario where we said, okay, we might have this idempotent bootstrap configuration, which we can trigger multiple times, always reaching the same state eventually. But we can also imagine this dynamic case where we have an initial bootstrap, but then there are some dynamic parts to the whole thing where where possibly some users might be able to add some code, or admins alter post-deployment, some configuration for whatever reason, I don't know. There were different scenarios for which this might be the case. So we had this requirement for a replayable configuration at the moment. You know, we needed to trace that set of dynamic configurations in some sort of manner. So let's briefly walk through that scenario where, again, at some moment in time, we have this deployment, we trigger our configurations, and then, differently compared to the first scenario, there's some user input which we have absolutely no control over as developers. Let's assume they add another client, a confidential client that they need to integrate a certain application into the landscape, which is not part of the static set of configurations. And then, because the script kiddie is really bored during his weekends, 3 p.m. on a Saturday, he tries again to hack our Keycloak instance. And again, our manager calls us and be like, you're ruining my weekends, figure it out. And we say, we don't care. Why? Because we came up with something even cooler. Who here is familiar with event sourcing? Can I get a show of hands? Okay, very, very few. So to briefly give you an introduction then, event sourcing basically means that any state change that you're introducing to your system, you're doing that on an event base. So for example, let's take the example of a creation of a user. That basically means that I call the endpoint, and the endpoint acknowledges the request that I requested a user creation and stores an event in the system that is being processed. It's like, you can imagine it as a Kafka queue where you publish the event to, and then you have somewhere in your application an event listener that listens to this user creation command, and it creates it. But a user is never actually stored in the database. The only thing that is stored in the database is the event of the user creation. So whenever I want to compute the state of my application, I retrieve all the events in chronological order from my database and replay them to get to a representation of the state that I'm currently at. So we thought that this event sourcing might really help us because, let me go back one slide, whenever this occurred, we can only go back in time, redeploy our application, trigger the set of configurations, and then replay all the events that happened between here and there to get to the same state that I was very shortly before this attack happened. And that basically brings me to the same state that I was in. So let me briefly show you what and the same configuration that we've seen in the beginning looks like as Java code. And I will very briefly change this one because I need to see what I'm doing now here. Where is my Keycloak instance? There. So I prepared this one here. This is the configuration as code demo. It's actually open source. I'm writing a lot of blogs on how to achieve different configurations. You can find me on GitHub and actually look at this code. So you don't need to take any pictures because, feel free to also contribute on it. So let's start at the beginning. We just have a configuration application where we, as you've seen in the screenshot, built up a Keycloak client that allows me to connect to my Keycloak instance. And then in this particular case, I have a realm configuration that exposes a realms resource and allows me to configure a certain realm. And in this case, I want to create an example configuration with an example realm. In this case, let's update. Sorry, in this case, I'm at the wrong spot. So in this case, this is the jar file, that was being created, and it was packaged into my Keycloak instance, creating an example realm. So whenever I execute this project, I actually, let me briefly do that to just show you how quickly this goes. Let me see if that opens up. So I'm shutting this down. I want to show you how quick this is, okay? So we shut down the current one. And then basically what we do is we do a maven clean package of the project running this will actually have me end up with two targets. One being the Java, it's readable, right? The Java configuration jar. And in another module, we have the Keycloak image. And then in this Docker file, this is a really quick example, but basically I have a builder that copies the Keycloak target into my Docker image. And I'm also placing the Java configuration jar into a subdirectory of Keycloak. And then when I do docker compose up, and let's pray to the demo gods that everything will work and all ports are free. Last time it didn't work. My prayers were not heard, but it should. Okay, so we're spinning up a Postgres database. Health check, timeout. Let's go. Yes, here comes Keycloak. Keycloak is starting up in a very clean state. It's just a basic Keycloak image. Keycloak is healthy. And now there's a third step, which is waiting for the Keycloak health check, where we should see that the Java configuration is being executed. Let me briefly make this a little bit bigger. So we're seeing some log statements, but basically in the end, what we're seeing here, finished Java configuration without errors. So let's move back to, not Slack, but where's my Chrome? Here. And I'm switching to the Keycloak instance that we've just started up. It removed everything, so this is no trickery or anything. Let's go to localhost 8080. I go to the login. And yes, I know, don't hack me again. I end up with a master RAM and actually an example RAM. So let's assume the dynamic case, where other users also insert data. For that purpose, I just implemented a very small, let me briefly quit this because this is not cool. I just implemented a wrapper API, basically doing the same thing that I have a Keycloak client and a client builder, exposing two endpoints where I can create a realm, sorry, that one, where I can create a realm and where I can create a realm client. So let's briefly call these. This is Postman. I'm not sure I can make this any bigger, but let's create a realm and we call this Devoxx Greece and Devoxx Greece. And just for, I think I'm not allowed to have any spaces in here, so I will write this like this. Let's say send. And I get 200 back, and let's refresh our page here and see, hey, there's my Devoxx Greece realm. We can all, same pattern. Let's say we want to create a client on this one, Devoxx Greece. And we say clients and create, and this is just a test API client. And I say send, get back a 200. Let's go back here, refresh this. We switch to the Devoxx Greece realm, go to clients, and it should show up here, test API client. So the only other thing that this application will do in the background in this API is actually keep track of these events that are happening, you know, for the creation of a realm or creation of a client that is user inserted, or I don't know, you know, basically anything that our API introduces into Keycloak is traced by events. And whenever we face a Doomsday scenario, we will just replay our configuration, our events. Thank you very much, guys. So let's trigger this again here. And sorry. So if you have, it should start. If you have questions, you can just insert them here and they will pop up. It's nice so they're not having a micro, so I'm very happy to answer any of your questions. I'm not sure how I'm doing on time, but I think we're almost done. Okay, so we have the first question is, do you recommend SQLite for small projects? I think that, I mean, it depends on small projects. If you run in production, always never use the database that Keycloak comes packaged with. You always need to externalize it. Which database you will be using, I think that's up to you. I don't think there's any upsides or downsides. I'm very used to using Postgres because it goes really well, and I think I've worked mainly on larger projects with it, and I really love working with Postgres. So I hope that answers your question. How to back up how to back up users? Their passwords are restarted. So basically what we did is, what I said is we externalized users and credentials, password, anything from Keycloak. Keycloak was talking to internal services that were not exposed to the outside world. So even when restarting Keycloak, we never had to touch the users or anything. If you keep the users and passwords in Keycloak, you definitely need to think of a more elaborate, mechanism on how these replays should work, and also how you store keys of Keycloak and how you back them up to be able to, when redeploying Keycloak, be able to check if the passwords match again. So you would really, this is some more elaborate logic that you would need to think about then. Another question is it easy to update the custom image to newer Keycloak versions when they are released? Short answer, yes. Why? Because, in most cases that I have done upgrades, it's mainly raising in the dependency management, the version of Keycloak. And then sometimes you need to alter payloads that you're sending to the Keycloak Java Admin Client, or that some setter became required instead of being optional. So you might face some errors, but usually they're caught very early during the unit and integration test phase. Unit not so much, but especially the integration test phase, where a certain call just fails because, you know, the description of a realm became mandatory instead of being optional, just as an example. So no, to be short, I've never faced any very complicated migrations. Let me see what else we have. How do hackers reach the Keycloak instance? Is it publicly accessible or internally deployed? I mean, obviously there are two different scenarios, right? Where you use Keycloak for your internal employees and it's hosted behind a VPN whatsoever, then you will not face this particular apocalyptic scenario. But if you're a publicly facing service and you're providing your clients with logins, most Keycloak instances are facing the internet. And all the endpoints are facing the internet. So you really need to think about how to protect your Keycloak instance. Okay, guys, so I think if you want to come talk to me afterwards and I will answer more questions, I will, but nice. This will end up on YouTube, I think so. Hi, Mom. Thank you so much for coming, guys.